Assalamu alaikum. Welcome, boys. I hope all of you are doing just fine. And you have prepared the previous lecture that was about enumerated data types. And now, as we all know, it's a collection of all the possible values that a variable can have. So today we are going to go ahead and discuss about the pointer data type. Now, a pointer data type is a very special kind of data type. It is not actually storing a value. A pointer data type actually stores the physical address of a variable which is actually the memory location allocated to the variable. Now I hope you are all able to see my screen clearly. Yes. So this actually is the pointer variable. Notice what is the pointer variable is holding. Pointer variable is actually holding the address, the memory location. And when we go to that memory location, following this arrow, if you go to that memory location, you would see that that memory location is actually pointing to a variable. So you can say that if you have a variable B, then pointer of B would be its memory address. Yes, hello? Can you boys hear me clearly now? Okay, we are talking about the pointer, and I told you a pointer is a variable which is not holding the value, but it's actually holding the physical address of the variable, means the area where in memory your variable is located. Now you can see that this pointer variable is holding the physical address, and when you go to the physical address in the memory, you can see that the variable is located there. This actually is called referencing the variable. Now, if we are actually programming at a lower level, we can actually have access to the pointers. We can determine where in the memory we want to save or make our variables. And but in our .NET framework, it is done automatically for us. I will explain in a bit how. Now, where a pointer data type is usually used. First of all, it is used to reference a memory location. The way to write that in pseudocode is this. First, you declare a type, you make a type of pointer variable. You remember that this type and end type area is used to make the custom data type, user defined data type. And then when you have declared this data type, which is t my pointer, then you can declare a variable using that data type, which is declare my pointer as t my pointer. A special use of pointer variable is to access the value stored at the address pointed to. The pointer variable is said to be dereferenced. Now, if we go back one slide, now is according to this diagram, you can easily see that this value 10 can also be accessed by this pointer value. We can actually use the physical address and access the value. If we access the value by mentioning the name of the variable, we are referencing the variable. If we are using the variable name to get the value, we are referencing the variable. And if we are using the pointer value to get our value, we are dereferencing the variable. So if we are using the pointer value to get the actual value of variable, we are dereferencing the pointer variable. Now, where are pointer used? Let's talk about some common uses of pointers. And before we do that, uh, just quickly recap one thing. We used to make a data structure called array. And an array used to have two things. One was its value and the other was its index or subscript. So if this array is called my list, so this would be my list 0, my list 1, my list 2, and my list 3. And then in these areas, I can have my values. I can have some value stored here, some other value here, and another value, and another value. What is happening here is to get this value 14, what I need to do, I need to go to the index number 1 of my list. You have done that in your AS, you already are familiar with it. So if you are doing this, you are actually using pointers. If you are actually accessing the values stored in an array, what you are doing is that you are using pointers. The indexes of the array are actually behaving just like the pointers because they are pointing you to the values. So the first and the common use that you have done is getting the array elements, then passing arguments by reference to a function. Remember when you used to pass a parameter by ref, you are passing a whole variable to a function and that function is having the right access to that variable and it can update the value in that variable. When you are doing that, actually you are using the pointers and creating data structures such as linked list. A linked list is a data structure in which each node is pointing to the next node. For example, a rough depiction of linked list would be something like this. These big boxes are called the nodes of the linked list. And let's call this node 0, this is node 1, and this is node 2. And this little part is the pointer area of the linked list. So node 0 is pointing to the node 1, and node 1 is pointing to the node 2, and node 2 is pointing again back to the 0. So what they are doing is they are essentially pointing to some other nodes. And the last node is again pointing to the first one. So this is called circular linked list. It is just a data structure. We are going to study them in a lot more detail when we get to chapter number 23. But right now, you can just assume that there is a data structure in which each node of the data structure is pointing to the next node. And such kind of data structure is called linked list. Okay. Moving on. Sorry. Okay. Before I move ahead, I would like to tell you that in VB.NET, there is a structure called int pointer, which can be used as a pointer handle. But actually, in the .NET framework, the pointers are managed by CLR, Common Language Runtime, and the memory is managed, assigned, and allocated by the CLR. So the programmer does not have to actually assign the memory by themselves. Whenever you have been creating a variable, the .NET framework is actually managing the memory for you. So in the .NET framework, you don't have to actually go to that grassroots level and make your own pointer variables. Very rarely a programmer come across doing such a thing. But when you are writing operating systems or compilers using C language or something even more specific, so in that sort of work, you might need to use a physical address of a variable, means a pointer variable. This brings us to the next topic, which is composite user-defined data type. In a composite user-defined data type, the data type is defined by referencing at least one or even more data types and combining them together. So when I need to make a data type which can hold multiple kinds of values, I would like to go for a composite user-defined data type. Let's start building our concept from the root. Remember, the variable was a box which can contain a value. Now let's say I want to store the student name in that box, and that box would be a string. So that box would be a string. That's just crude typing. Let's Now this box is going to store the name of the student, and then I want to make another box which store the student ID. Now we are all very much familiar with this. And if that ID is totally numeric, so we can use integer data type with this one and string data type with this one. So this one can be integer, and this was a string name. Let's put it right here, name. Now what if I want to make one data type which can hold both of these values together? What I want to do now is I want to create one box which have its own little compartments in which I can store these two different kinds of values. When I do this, it is going to become the composite user defined data type, a data type with reference to at least one or more other types. Let's see how. To make the composite user defined data types, what I'm going to do is I'm going to use a command called structure, and I'm going to declare a structure named student. And in that structure, I'm going to define now compartments. So dim name as string and dim student ID as integer. Now what is going to happen in my submain, again, I defined the customized data type in my module one, not in my submain. As I showed you that enum command was not valid in the submain. And if I put the structure command in submain, it is also going to cause an error for me. Now I can go in my submain and create a variable, for example, student1, and I can create it as student. Okay, we are back again. Sorry for this lagging again. So what I was saying is that this structure student is a composite user defined data type in which I have defined two compartments. One is a string and the other is an integer. And then I went ahead and I declared a variable in this data type named as student. Can everyone see the screen? So what I can do here is I can take input from the user . Oops. I can take input from the user and I can store it inside the different compartments. Like student one has its two compartments. I can use the dot as reference operator and enter name. So the value would be going inside the student one dot name. And then I can just copy this whole thing and enter student ID, which can again go inside student1 dot student ID. And to get the data out of here, I can use the old conventional method, console.write line. I can write the name is a placeholder 0 and the student ID is another placeholder 1, and then I can just start putting in my variable student1 dot name would go in the first placeholder and student1 dot student ID would go in the second placeholder. When I run this, you would see that there's the student name and there's the student ID printed in front of you. Now, what I want you to focus here is that this is the variable that I created, student1, and it is created as a student. So the student here is our record data type, a composite data type that we created to store our records. Now let's get back to our presentation. A composite user-defined data type has a definition with reference to at least one other type. It can have more than one data types in the definition as well. Like what I did, I actually used more than one data types in the definition. The data type string and integer were used in defining the data type student. This is a pseudocode example of how can you define a composite data type. You can see this type is actually T employee record, and you're declaring the name as string, the family name as string, the date employed as date, and the salary as currency. When you make this, you are actually making a data type which holds not one, but four different compartments for four different kinds of data input and output. Let's get back to our book, that is page number 247. I would encourage that you people go through these 247 and 48, and then we have set data type. Now, a set is a structure. A set can be a list, a set can be an array. It's a data type which allows us to do the mathematical functions. Mathematical functions like union and intersection. They are very common with the set theory. In the worksheet which is going to follow this lecture, you're going to see a question which is going to really test what your programming skills are. You're going to have to make two different arrays, and then you are going to make a third array uh, in which the union of those array, and then a fourth array in which the intersection of those array should be stored and displayed. So set data type allows us to create sets of data and allows us to perform different mathematical operations onto that data. This is where I'm going to end the class, and now we are going to have the question answer session. Thank you all.